So 21. Yeah. So it is good to go. Good morning, dear students. So today in our class, we have the agenda of discussing with the token ring, wireless networks. Kindly mute all. Leading wireless technologies, working of wireless technology, Wi-Fi 802.11, we call it as there is a number given for each technology, communication technology by IEEE, that is 802.11. Physical properties of Wi-Fi and collision avoidance in Wi-Fi. So that is what we are having. Okay. So what is exactly a token ring? Token ring is actually a topology. So just like your LAN, which is a bus topology, that is Ethernet is just like a bus topology, whereas a token ring is connected, one end is connected to another end, so forming a ring. For many years, there were two main ways of building a LAN. So one is using Ethernet, another one using a token ring. So most prevalent form of token ring was invented by IBM and is standardized by IEEE. So Institute of Electrical and Electronics Engineers. So way back in 1970s, and they named it as 802.5. So token ring, they have named it as 802.5. And token rings have number of things in common with Ethernet. So one is ring behaves like a single shared medium and employs a distributed algorithm to decide which station has to transmit on the medium, so at a given instant of time. So every node on a given ring can see all the packets transmitting by other nodes. So it is just like when you are in an airport where all your luggage launch will be rotating just like that. So you will be seeing all the luggages, and once your luggage comes, you pick. So it is just like that. So same thing. And the most obvious difference between token ring and Ethernet is the topology. Where the Ethernet is a bus kind of thing. The nodes of the token ring are in the form of a loop, and that is each node is connected to a pair of neighbors. That is, one is upstream, another one is downstream. Upstream, so towards right, and downstream towards left. And this is the technology. So the main intention is, so whenever a station wants to transmit the data, so what it will do, it will hold a token. Token is a special bit of packet that is been transmitting. So the station which holds the token is allowed to transmit the data, and all other stations, they have to listen. So this is one of the very popular connectivity thing. So the token, which is nothing but it's a special packet, special bit pattern, which is a packet, and of course so the token which holds that the station which holds that token, so can transmit. So all other stations can listen. So that is the condition. And of course, many different variants of token rings appears over decades with fiber distributed data interface. Even today, this FTDI is being one of the very significantly used networking. So if you see FDDI, so the advantage of FDDI is that is ring topology is, even if one station, one line cuts, if the upstream cuts through downstream, you can transmit the data. So regarding this, you have the experiment. Probably this week, end of the week, we'll discuss about the token ring experiment. In this particular week, we'll discuss and we'll understand what is that. And in the end, the token ring lost out to the Ethernet, especially with the advent of Ethernet switching and high-speed Ethernet variant. So it can go up to 100 megabits per second. So 100 Mbps to Gbps, and that is the advancement that we have. So normal interconnectivity of a token ring is 100 Mbps. Whereas if you take FDDI, the fiber distributed data interface, which is also very common to a token ring kind of thing. But only thing is you use fiber optics for interconnection of two computers, or upstream or downstream computers. So when you use fiber optics, the speed at which the data travels is in terms of gigabits per second. So that is we call it as gigabit Ethernet. So that is another thing. Next, we have wireless communication. Wireless communication is one of the most used, most popular communication. Today we have Bluetooth. Today we have mobile connectivity. We have smart connectivity, Wi-Fi, whatnot. So a lot of things are there. Even our infrared rays is also RFID. So I have both. My TV works with IR, infrared. So through my remote control, I control. Similarly, I have my Videocon DTH. So in Videocon DTH, it is, the remote is totally operated by RFID. So in any direction, if I change the, if I operate my remote, it works. So RFID is also one of the communication technology. Bluetooth. So we generally transmit voice. We transmit voice and other things through Bluetooth. So Bluetooth is one very popular kind of Bluetooth is another popular device that certainly it is being used. So moving further, wireless technology differ from wired technology in some important ways. And when you look into the wired technology, while at the same time, it, so wired technology will be having only a fixed medium. But in wireless, since the transmission is through air, so we have uh, many common properties that are being shared. But like the wired links, we the issue of what we call it as the issue of bit errors are great concern in the case of this wireless technology. Typically, even more so due to unpredictable noise, environment, and the air we cannot predict due to electricity, due to lightning, due to the wind, speed. So automatically, what happens? We tend to lose our connectivity. So that is what we call it as wireless. Wireless links are subjected to a lot of problems, but still they are popular. Framing and reliability are also have to be addressed. Unlike wired links, the power is the big issue of wireless. What is the meaning of power? The signals, whatever you send, so they'll not have much strength. So you should give you should use high powered signals, so that if you use high powered signal, the environmental difficulties we face, the small birds, small animals, in fact the small kids will get affected. So it is very very important sensitive issue. So um, power is a big issue with respect to wireless, especially because wireless links are often used by small mobile devices like phones and sensors that have limited access to the power. So that is the thing. The problem with wireless. So wireless media are also inherently multi-access. It is difficult to direct your radio transmission to just a single receiver, or to avoid receiving radio signals from any transmitter with enough power in your neighborhood. And of course, hence, the media access control is a central issue. Controlling the media, so who has to access the entire medium is the central issue for wireless links. And because it is hard to control who receives your signal, and when you transmit over air, so the issue of eavesdropping. Eavesdropping means you transmit you transmit signal via air. So anybody can hear, anybody can understand, anybody can easily uh, you know uh, do the things, receive the data. So if somebody other than whom you are intended can also receive the data, that's what we call it as eavesdropping. Eavesdropping may also have to be addressed. So if you tend to send it to node A, so it has to reach only to node A only. It should not be reached to any other node. So that is what you call it as eavesdropping. And uh, um, there are leading networking technologies. We have the Bluetooth. The typical length will be 10 meters. Beyond 10 meters, it will not. The maximum data rate that you can achieve is 2 Mbps, and generally it is used to link peripherals and computers. Today Wi-Fi systems like music systems, remote can be used. And of course normally you can also use instead of USB, sorry, instead of Bluetooth you can use USB. USB is another technology to use. So either you can transmit the data from your phone to laptop through Bluetooth, or you can transmit through USB. Or I think today we have a Bluetooth mouse. So using Bluetooth mouse, you can connect. So when you use a Bluetooth mouse, it is of course mouse will be communicating through Bluetooth. The alternate is, so you should have a wired connection through USB. That is an alternate technology to this. Now, the second technology is 802.11. 802.11 is actually Wi-Fi. Wi-Fi, it can go up to 100 meters. So 100 meters length it can go. And it can transmit up to 52 Mbps, okay, in a shared medium. And normally it links a computer with wired base. Wired base in the sense there will be a base internet connection. So to that internet connection, your Wi-Fi can connect. So the alternate technology that we can have for this is Ethernet. And next one is 3G, a cellular phone. Cellular phones can go up to 10 kilometers, and hundreds of kbps per connection you can certainly have. So today we can see up to 100 mbps it works. In fact, it is 3G is up to kbps, but 4G what we are experiencing today, so they go up to 100 mbps speed, and links a mobile phone towards wire tower, and towers to tower there is a internal connection, wire connection. So the alternate is digital subscriber line, DSL, the landline phones. So it is just like that. Okay. So working of wireless, how exactly it works. So observe here, you have many clients, and each client is a transceiver. Transceiver is nothing but it can receive and it can also transmit, like your laptops. And you are connected to a base station. Base station is a transmitter as well as receiver, so it can receive the signals and also it will transmit the, and this is wired connected to the network. Okay. So in the college itself, we have Wi-Fi hotspots. So when we have Wi-Fi hotspots, so these Wi-Fi hotspots can connect to the laptops, and of course, the hotspot or the router is connected to wired network. So it is just like that. So in many wireless networks today, we observe that there are two different classes of endpoints. So one endpoint, sometimes described as the base station, usually has no mobility. Base station is a fixed station, but has a wired connection, so that is having at least a high bandwidth. The connection to the internet or to the other network. So as shown in the figure. So you have the connectivity here. So the connectivity, certainly you can, this connectivity. So you can certainly think, so there is a connection, base station is connected to the network, disconnected to the network. So that is what you can see. So it is connected to the network. And uh, further, we can think of the node at the other end of the link shown here as a client node is often a mobile, so which relies on its link to the base station for all its communication with the other nodes. So remember, so this base station is the responsible for providing IP address, providing connectivity. So within the range, it should provide the connectivity. Yes, that is the main concept here. So Wi-Fi is standardized as 802.11, and you can see most readers will have used wireless network based on 802.11 standards, often referred to as Wi-Fi. And Wi-Fi technology is a trademark owned a trade group called Wi-Fi Alliance, which certifies the product alliance with 802.11. And of course, like Ethernet, 802.11 is designed to use in a limited geographical area, maybe in office, maybe at home, maybe at the campuses. And its primary challenge is the immediate access to share communication medium. In this case, the signal propagates through space, and of course, properties of Wi-Fi. So first property, 802.11 defines the number of different physical layers that operates in various frequency bands. And if you look at each router will be transmitting in different frequency bands, provide a range of different data rates, and of course at the time of writing or developing 802.11, this is the highest version. So the highest maximum rate of top out is 600 mbps. So we are about to get 600 mbps, but today we are getting in gbps. Okay. So the original 802.1 standard defined two radio based physical layer standards, one using the frequency of 79.1 megahertz wide frequency bandwidth, and the other using direct sequence of spread spectrum with a 11-bit chipping sequence. So normally the data used to transmit using this megahertz, say 79.1 megahertz, and both provide the data rates of 2 Mbps range. The physical rate layer standard. So 802.11b is added. The next version of the Wi-Fi is 802.11. Similarly, we have 802.11 provides, it's a small change development in internet Wi-Fi technology. When we do this, so it used to carry up to 11 Mbps, and of course there are three standards of operating licensing, which works at 2.4 gigahertz, the frequency band of electromagnetic spectrum. So earlier one was radio wave, and now we have electromagnetic wave spectrum. Then comes Intra 2.11a, which delivers up to 54 Mbps of variant of FDM, frequency divisional multiplexing, and it is also called orthogonal frequency multiplexing, where it used to transmit data in 4 directions. Four waves are sent in same. So 4 waves in the sense, if you look at the wave parameter, so one wave horizontally, one wave, another wave vertical wave, another wave is so in all 4 directions. So you can expect the data to be transmitted. So orthogonal frequency transmission, 802.11a runs on license. So you need to have a license in order to run this particular thing. Now, on the one hand, this band is less used, and so there is a less interference. Of course, there is more absorption of signal, and it is limited to almost line of sight. 802.711g is followed, and 802.11g is one of the most popular. Also used orthogonal frequency division multiplexing delivers up to 54 Mbps, and it is backward compatible with 802.11b. So these are all some of the physical properties that one can expect from Wi-Fi. And further, 802.11, which was released in 2009, and which is the treated as the latest. And today we have 802.m also. So 802.11 archives considerable advancement in the maximum possible data rate using multiple antennas and allowing greater wireless channel bandwidths. So most of the devices today we use 802.11, and you can also check in your mobile phone if you make it as hotspot. So what happens? Your mobile operates like a antenna, and it will transmit the data. So in that, I think probably it will transmit in 802.11 standard. That means it can go up to 100 Mbps. So the use of multiple antennas is often called MIMO. So multiple input and multiple output. That's what we consider. And so one of the major problem we come across with respect to Wi-Fi network is collision avoidance. Collision avoidance, the packets will collide. A lot of packets will collide. How to avoid this collision? So that is the main issue here. At first glance, it might seems that a wired protocol would follow the same algorithm as Ethernet. Wait until the link becomes idle before transmitting, and back off should have a collision occur. And of course, to the first approximation, this is 802.11, what 802.11 does. So in normal link wired network, so you can certainly consider for waiting for link to become idle. But in air, how you wait for a link to become idle? So it is a common. But the additional complication for wireless is that while a node on Ethernet receives other nodes transmission and can transmit or receive at the same time, neither of these conditions hold in wireless. Of course, in wireless, so medium means air. So in the air, so how can you just guess whether data you are transmitting is free from collision? So that is one very important thing, and this makes the detection of collision rather than more complex. The reason why wireless nodes cannot usually transmit and receive at the same time is because they transmit on the same frequency. Okay, so the reason why node may not receive a transmission from another node is because that node may be too far away from or blocked by an obstacle. So sometimes what happens, if you have an obstacle can also block your transmission. So these are all some of the issues with respect to network, wireless network. We'll discuss in detail. So there are problems. There are a lot of problems we discuss with we discuss. One problem is exposure problem. Another problem is hidden problem. So hidden packet problem, another one exposure problem. So hidden node and exposed node problem. It is most common problem in Wi-Fi network. We'll discuss that in the next class, along with the distributed system of wireless network. How exactly we can have a distributed network through wireless, and also we discuss Bluetooth network. So in the upcoming class, that's all for today's class. Have a wonderful day. Thank you. Um, Today we have to remember today Samvidhana Shilpi Dr. B.R. Ambedkar's birthday. So we had to pray for social justice and work in his guidance directions. So today's class recording is available in this website, and the study material notes PPTs are available in this website. That's all for today's class. Thank you.